All right, welcome everybody to this episode of Code and Coffee. It's our second episode so far. Today we're going to be continuing through a project that I started in our first episode. But before I do that, I wanted to just do our little commercial announcement here. This Code and Coffee episode and all Code and Coffee episodes are brought to you by EnergyPro.com. You can see their tagline up there, your one-stop shop for free training, tools, resources, design to help industry professionals decode California's building and appliance energy efficiency standards. As you're probably well aware, our energy standards are probably one of the most complex in the whole nation and the most stringent. So let's get into our introduction. So you'll see my happy little face up there in the right hand corner. I can't. This is hard to do. So I also wanted to share with you, some of you who are tuned in live here. We're going to be giving away something really cool. I'm going to go to my over-the-shoulder view here real quick. See this coffee mug? The YouTube channel is called Code and Coffee, and we have these awesome Energy Code Ace coffee mugs. Look at this. You rotate that around, it says Energy Code Ace Code and Coffee. We're going to be giving this away to a random winner. What we ask you to do to qualify for this is you got to subscribe to the Energy Code Ace channel, and you've got to make a comment. Well, I'm not going to make you a comment. Just subscribe to the Energy Code Ace channel, and I'm gonna pick a random winner, and I'll contact you, and we're going to give one away. So really exciting. Let's get back to our introduction. Today we've got a fairly short episode, but what we're going to do is we're going to be continuing where we left off in our first episode. So if you have not watched that, you can click on that after this program and go through where I modeled a simple new construction project from start to finish in 1 hour. I went through doing plan takeoffs. We used our Bluebeam software to do the plan takeoffs. I input all the data into EnergyPro, ran the analysis, reviewed the CF1R for accuracy, and it was a pretty fast-paced show if you've watched it. So let's see if we have anything in the chat window. Lindsay, is there anything in the chat window that I need to address at this point? No? Okay. For those of you on the show, I've got this headset on, and my producer Lindsay and my tech person Zach are talking in my head here. So anyways, just try to keep everything fresh, keep everything on track, and deliver the best content we can. So back to our project. Today what I'm going to be doing is inputting overhangs and possibly sidefins in our model. So if that interests you, please hold on for a real fast-paced demo here. So not only are we going to enter this information, we're going to take a look at the plan and see what type of overhang or sidefin should be entered into the software. So and then of course once we're done, we're going to review our CF1R for accuracy, make sure that we got those inputs correctly. So let's jump to our set of plans here. So this might look familiar to you. This was our simple new construction project. I've got I'd like to start with the plot plan because get everybody reoriented to this project. Let me see if I can get it to regenerate. There we go. So here we have our simple new construction project. This is on a fairly large lot. North is to the top of the page. So the back side of the house is kind of northwest facing. The front is southeast facing. So we want to kind of boil it down to what orientations are going to take advantage of shading the best and reduce our overall TDB energy use when we model it. We also need to look at the plan and see if there are any substantial overhangs that might do that. I looked right here and I see the porch across the front I see a covered porch across the back in this plot plan. But let's take a little bit further view of this. If you're not familiar with Bluebeam, the software that you're seeing right now, it is a paid software. I think it's like around 300 bucks, but really good, powerful software. So we've got a porch. It looks as if it's covered on the front. We've got a porch that appears to be covered also in the back. Let's go to our elevations here. Wow, here we go. So we've got a nice covered front porch here. We've got this entry that's covered, but you know, my concern here is that while it's not an opaque surface. That's an exposed beam, and sunlight can go through there. It probably isn't going to be very advantageous to model this because you know, the likelihood of that window being shaded or seeing any advantage of that shading because of the distance here is so high may not be practical, but definitely these windows here, we can model those. Let's take a look at our side elevations. I always like to go clockwise, so front we'll go to the left side. Here's our overhang. We've got a big gable end. Those windows are in the garage. We don't need to model those. So this would be, I would say this is southwest facing. Unfortunately, we don't have any overhangs here. We don't have any side fins to speak of, so we really don't have much to do on the left side. Let's take a look at the rear elevation. So we've got some overhang. Looks like about a 2-foot overhang on this window, on this sliding door here, and on this sliding door over here. But we have this nice big overhang. I think it's about 12 feet deep, and you know, that's something that we could take advantage of. It looks like there's also a flat roof over that. So so there's a good possibility. This is again on the northwest side of the house, so I like to keep in mind that anything east, south, and west facing is going to make an impact on our TDV energy use, basically reducing the amount of solar gains to those windows in those orientations. Unfortunately, north facing windows are never going to get any direct sunlight and really isn't going to have an impact on our overall TDV energy use. So another reminder I want to say is that overhangs and side fins are a voluntary measure. You don't have to model these. It's your choice as an energy consultant to model them or not model them. And yes, there are some times when it's to your advantage not to model an overhang, and that's perfectly acceptable. If that modeling that overhang causes your compliance margin to go down, get rid of it. Now, you're not accurately modeling that building, but it's perfectly acceptable within the standards to use that strategy. So use it when it's an advantage to you. Don't use it when it counts against you. So, all right, back to our model. So I think we've got some good information to get started here. I'm going to jump back to our floor plan and start looking at some of these inputs. Now, you may have followed along on the first episode where I did my takeoffs. I'm really not going to go backwards into that, so go back to episode 1, part 1, and take a look at that if you'd like to look at the takeoffs. What I'm going to do is just start right from here. But keep in mind, I always start my models, and this is just my best practices that I've developed over the years, is I always start with the front wall and go clockwise. I always start with the front right window and go clockwise. That way, when I do have to go back into the model, and you'll see, I'll go to my EnergyPro screen here, you can see my tree. So here's my front wall. My front window is 8.75 square feet, which is representing this window right here. Now, I did all these windows individually. You could have lumped these two 2636 windows into one window, a 5036. May have made your overhangs and side fins a little bit easier. So let's start here and let's look at the characteristics. Now, our inputs in EnergyPro, I'm going to jump back to our EnergyPro screen here, for overhangs are going to be our Horizontal projection, that's the distance from the vertical wall or the window out. So how deep is that overhang? What's the distance above the window? We're going to take a look at that. Left and right extensions. Flap extension down, that's like if you had a fascia that extended down below that the soffit. So I rarely use that, and in some situations I do, but we might take a look at that today. All right, so we're going to gather some of this information on our plan here. Since I individually input these windows, I'm going to input that into EnergyPro individually. So we got a 2636 window here. It's our first window, number 1 on the front side of the building. Let's take a look at the section, see how far that overhang actually is. We got to thumb through our plans here. So a little bit of a delay. Sorry about that, guys. We could look on the roof framing plan. We could just do a real quick length check on that. It looks like it's about 8 feet, but look at that, 8 feet right on the money. We also need to know how far, what distance it is from the top of the window to the bottom of that overhang. So I like to go to my elevations to figure that out. So I'm going to go in here and say linear dimension length. I'm going to go from the top of the window, not from the trim. We don't want to go from up there, but just to the bottom of that overhang. So it looks like about 7 inches. So other than knowing the right and left extension, I think I got all the information I need. So let's go back to EnergyPro. Let's enter this information. And I apologize that this may not be as big as you would prefer, but I'm going to start with one of our pre-done examples here. I like to move it to the bottom because I'm going to be adding several of these. So you can see these little up and down arrows move these. So I've got an 8-foot overhang, and our distance above the window is 7 inches. So I'm going to say that's 0.58 feet. So here's our, keep in mind, that's just a descriptor. That's my my user input name for this overhang. I like to add some descriptors behind it too, to differentiate between different right and left extensions. So 8-foot overhang, the distance is 0.58. Left extension, how far to the left does that overhang extend? So we go back to Bluebeam here, take a look, and really this is a toss-up. I mean, we could measure to the end of that overhang, which is about a foot. We could go all the way, that extension doesn't go all the way out there, so I'm going to call it a foot on that one. So our left extension is a foot. Our, no, I'm sorry, it's more than a foot. It's going to be 2.5 feet, right, because of that window. So 2.5. Right extension is going to be about 6 inches. We could measure that where it butts up against this wall. Yeah, 6 inches is good. So 0.5 feet. Now I like to indicate this just so I know which overhang I'm looking at. So I always input in parentheses. I go, okay, left extension is 2.5, right extension is 0.5. That way I can identify it real easy. So I'm going to go ahead and select that. I think I've got all my characteristics in there. And now it's asking me for a window width and height. If you don't input the width and height, your overhangs aren't going to calculate. So we know this is a 2.5 feet wide, 3.5 feet high, and we're done. Window 1 is done. Let's just go ahead and work through these inputs here. We're going to use the same overhang and distance above characteristics for this next window, but it's going to have a different left and right extension. So Chandra says, why is the left window extending for your first window 2.5 feet? It actually should be 3.5 feet, right? So I'll go back and edit that. Good catch on that, Chandra. So we should be let's see. We've got to change this to 3.5 feet. So good, we've got that. And I think we've got some more people coming over from our old stream that may have been watching part 1. So hopefully we'll get them migrated to the live version here. So we've got this characterized right. Let's go to window number 2. We're going to use these characteristics here, and I'm just going to hit the copy button. So it's a copy of the previous one I used, and we're just going to change up these characteristics to be more like what's actually there. So let's go back to Bluebeam. We're talking about this window right here. So it's got a left extension of about a foot and a right extension of about 3 feet. So let's just modify that. So I'm going to change this to say 1,3. That's just for my purposes. This doesn't do anything to the characteristics. If you change the name here, it's not going to automatically change this stuff. So select that. I got to give that window a width 2.5 by 3.5 feet. Now we're getting on to our so you can see this in EnergyPro here. So I've got window number 1 modeled with overhang and our width and height information. Window number 2, we're getting onto our side light door, side light transom combination. So I'm going to go back to Bluebeam and kind of show you what we're talking about here. That's these set of windows here. So I've modeled this side light, the transom here. Unfortunately, this isn't going to really equate to much of a usable overhang because that gable end is open. So we have direct sunlight hitting those. This overhang's not going to be that effective. So I'm going to just pass it because it's probably not going to be worth my time entering that. But if you had a raked ceiling like this, what I would probably do here is give an average height. So take the distance from that corner up and the distance from the highest point there, average those distances, and then enter the left and right extension there. So that would give you the distance up from the window. That's technically how I would do it. I don't think there's any standard in the Title 24 Part 6 that would let you know that. But let's get on to our other windows here. We've got these windows here. So I've got more 2.6, 3.6 windows to input. So let's go ahead and continue. The overhang characteristics are the same for the projection, the horizontal projection, and the distance above the window, but we just need to alter the characteristics to demonstrate what the right and left extensions are. So let's go ahead and go back to our overhang window. I'm going to again copy that one I had. I'm going to go 8-foot overhang. It's 7 inches above. My left extension, it looks like that left extension goes way beyond 8 feet. Now you could enter the exact distance there. If it's beyond the distance of the horizontal projection, I just enter the horizontal projection. So you can see that here. So it goes from this point all the way to the end to the overhang there. So effectively, you know, you're not going to get any solar gains past the amount of horizontal projection to the left or right. But our right extension is a bit shorter. I like to measure that. It looks like somewhere in, well, let's call it 1.9 foot. So we're going to have 8 feet to the left, 1.75 to the right, and we're going to call that one good we just have to enter the width and height. It'd help if you could see the screen, right? All right, moving right along, we're going to do the next window to it, and this would be pretty simple. We're going to select the same one here. I'm going to copy it. You can see how you could get a whole lot of these going here. I'm just going to add 2.5 feet to that. So 1.75, it's going to give you 4.25 feet. So, oops, sorry, my fingers don't type well in the morning. So 4.25, good, and we'll give it a width 2.5. 1.5. I assume you guys are keeping me accurate here, right? You guys are following along. Good. Now we've got this set of windows done. We just need to input this last set of windows, a little bit bigger windows here. So we've got two 3050 windows, and we've got the same overhang and distance up characteristics. Our linear length from this edge over here to where the window starts is more than 8 feet. So this is an easy one. I'm going to come in here, go back to EnergyPro. I'm going to copy that overhang characteristics. I'm just going to go 8 feet left, 8 feet right, and call it good. Enter the window width is 3 feet, window height is 5 feet. I'm going to enter the same characteristic for the next window. So I'm going to go this 8-foot overhang, 8-foot left and right extension, and call that one good. I always like to hit the save button pretty often. So good. Any questions on our chat window so far? No? Looks like we have 10 people watching so far. That's kind of cool. Our numbers are slowly growing over time. So, and I'd just like to say thank you guys for watching. So this was kind of a vision to do this YouTube channel that I came up with, and I got a lot of support from our sponsors, and seeing you guys show up here and watch this is awesome. So, okay, we determined that our left wall isn't going to get any shading because frankly it doesn't have anything to calculate here, so no overhangs, but our back wall does. I find it an advantage in some of the higher exposure areas, meaning you're south facing or west facing. Late afternoon sun is what drives up our TDV energy use, right? Summertime, cooling. This is a cooling dependent climate zone. If you remember, I believe we modeled this in climate zone 12. So yeah, climate zone 12. So it would make sense to take advantage of all the shading. Even a 2-foot overhang is going to give you some TDV energy credit. So let's go ahead and do that. We've got a 3050 window here on this corner. Let's go ahead and model those characteristics, and let's kind of zoom in here. We got a little bit different above distance, so let's go ahead and determine what that is. So 1.2 foot above, and our right distance to that edge of the overhang is 4.5 feet. So let's go ahead and input those characteristics into EnergyPro. Again, no secret to hear what I'm doing. You can see I've got my blue beam information on my left little laptop monitor here, EnergyPro on my center monitor. Just don't look at the stuff on the right. That's the Mr. Wizard stuff going on. You can see the infinity thing going on in the background. So, all right, EnergyPro, we're going to input this characteristic for this 3050 window. We know it's a 2-foot overhang, so I'm going to take my 2-foot overhang default there. I just like moving them to the bottom. I like everything lined up, organized. So that's my OCD. 2-foot overhang. What did we say? It was 1 foot 2 inches. Rounds to about 1.1 feet. So make sure, don't forget to change it down here. If you don't change it down here, it's going to be inaccurate. 2 foot overhang. I've got, you know, I'm going to model this left extension is going to be, it goes on. So there's 4+ feet there. Right extension, there's more than 4 feet there. Anything beyond that is really isn't going to give you any additional shading. So west, kind of northwest orientation, it's you get low sun angle, and that sun angle is going to be lower than that overhang anyways in the late afternoon. So there's not a whole lot of advantage to modeling anything beyond that. But you're welcome to model it as exact as you want. So in this case, I'm going to call this one the 4 foot left extension, 4 foot right extension. We've got that covered. Window width is 3 feet. Window height is 5 feet. And that one's good to go. We don't model overhangs on doors. So it's already an opaque surface, so no solar gains there. Our next window is a 6068 window. Now, here's something that is a little weird, and you'll see this on the compliance documentation when we run it. You know, to get the appropriate dimensions, width and height for a 40 foot, you know, if you did the math, 6 feet times 6.6667, that's the decimal equivalent, gives you 40.0002 square feet, right? I always rounded to 40 square feet. But if you enter these width and height dimensions here, it's only to the first decimal point. So you're going to get a weird multiplier factor in that. So sometimes I'll go back and then change this area to be to reflect the width and height to the closest decimal point. So I'll show you that in a second. Let's model let's grab our characteristics for overhang. We're going to use the same one as before. The 1 foot 2 above, 2 foot overhang, 4 foot left, 4 foot right extension. So my width is going to be 6 feet. Because it only does 1 decimal point, I'm going to do 6.7 feet. So if you were to multiply 6 times 6.7, gives you 40.2. So just so I don't throw a plan checker off going, why is this multiplier here? I'll go back and edit that square footage. It's really going to have an insignificant amount of area on your overall compliance margin. So, and you're going more than what is actually there. So, I'm going to add that 4.2 just for clarity purposes. All right. Everybody good so far? Give me a yay or nay in the chat window if I'm going too fast. So let's so we've modeled these 2 windows with the 2 foot overhang. Now we're again, we're going clockwise from in this view, left to right, right to left. So now we're tackling this window here. I think this is a 3060 window. If we looked on the floor plan, we are right here. So we're going to be modeling the characteristics of this covered porch here, and it's actually extending out 12 feet. We know the overhang goes another 2 feet, and we can see that on the roof framing plan. I won't go there, but the problem is that that eave over the barge rafter is up at a rake, so we can't take advantage of the shading from that. You'll see that up here. So we're going to take the shading to this line right here. That's the end of the horizontal projection, and we need to, we know it's 12 feet because of that, it's dimensioned that way. We just need to know the distance up here. Look at that, how convenient. Nice round number of 2 feet there. So thanks Shander for the smiley face. I can kind of see that. It looks like a maybe the smiley face with the teeth showing. You know, that one. All right, so we know those characteristics. Let's go back to EnergyPro, and we know we have our 3060 window because it's 18 square feet, and I always keep these in order. So let's just enter those characteristics here. I'm just going to create a new one and call this 12-foot overhang. It's 2 feet above. Let's look at our left and right extensions. Forgot to do that. Left extension is 16 feet. We got that, no problem. Our right extension is, if you didn't catch that, I didn't do the dimension because it shows me it here, but there's the dimension there, left, and that's the right one. Oops, sometimes I get ahead of myself, click too many buttons. Right, I go all the way out to the eave. I don't go to the edge here. I go out to here because that overhang goes all the way out to here. So 16 feet. So let's go ahead and model these exactly the way they are. So let's go. Our left extension is 16 feet. And just remember, you can model this as accurate as you want. I told you before, you know, anything beyond that, you know, the left and right extension equal to the depth of the overhang, you know, isn't real effective. But in this case, we have a little higher projection above that window, and it might capture a little bit more. So, you know, just kind of do it for fun here. So we'll just change this 16, 5. Looks like we got everything going okay there. Got to give it a width, 3 foot and 6 foot. That window's good. This overhang, now we're going back to the window here. Our left and right overhang, we could figure this out, the math. There's a foot between here. You know, we could add it all up, but we're going to make it easy. Let's just use the blue beam here. It's 9 feet. So 12-foot overhang, 9 feet left and right extensions, 2 feet above. That's an easy one. Let's go back to EnergyPro. And just copy this one. Call it 2 feet above. Let's go 9, 9. Did I not change that overhang? See, I did it wrong. I changed it up here, and I forgot to change it down here. So sometimes I make mistakes. So all right, good. So our window characteristics are, that's a 6 foot wide by 8 foot high window. We're going to go back and do this last window over here. This 3060, and this is just the opposite of the one on the right. So we're going to have it copying this one. Back to EnergyPro, copying my 12-foot overhang, 2 foot above, 16 left, 5 right, and we're just going to copy that and just flip those left and right extensions. So I'm going to call it 5, 16, and flip these 5 left, 16 right, and hit OK. It's a 3 foot by 6 foot window. Good, we're almost done here. One more window. We can easily input that. It's our last, actually it's a door, so it's another 6 foot by 6 foot 8 window door. Let's grab these characters. I think this is the same. Yeah, 1 foot 2 above. We're going to go right extension. I'm just going to take it to the end here, so 3 feet. We are way beyond our 2 foot. So I think our original characteristic for the other windows over here are going to work just fine. So okay, so let's input that information here. So let's go with 2 foot. We don't quite have a 4 foot overhang there. I'm going to copy that and go 4 foot on the left, 3 foot on the right. So you guys are keeping me honest here. Again, it's a 6 foot by 6 foot 8 window, and we're going to adjust this so our multiplier factor for our window width and height matches our area. So 40.2 square feet. Good. Save that. Currently, if you look in the lower right hand corner, our original analysis, we had about a 6.1% overall improvement in our compliance margin. So any predictions on what it's going to be when we analyze this? You're welcome to type that. Are we going to see 5% increase in compliance margin? 1%? Kind of throw that out there. See what you think. So, but let's go ahead and take a look at our analysis here. So I have to do some behind the scenes magic here, because if I run the analysis, my system crashes. So let's see what our chat window comes up with. Chandra says 2 to 3. Cynthia says 3%. Yeah, I think you guys are right in the right range. So let's take a look at our analysis. So after running those windows, our savings jumps from what I say 6.3, 6.4 to 7.5. So not quite as much as we thought. Now keep in mind the orientation of the front was kind of southeast, so it wasn't, if that house was rotated more south, or actually more east, it would put our back wall being due west. So right now it's the back wall's more northwest. So let's take a look at our floor plan here, or a plot plan, so you can see that orientation here. So if that house was rotated more counterclockwise, let's say 45 degrees, I think it would have a much bigger impact on that. But because it's off a little bit, not as much. So, but hey, I'll take a percent, a little over percent. So that kind of puts us in that 7.5% margin. I've got a little room to play with. So let's take a look at our CF1R first. Let's see, I got to pull up the right one. So yeah, there it is. Let's take a look at our CF1R. We're going to check this thing for accuracy. So here we are at 7.5%. Now the way I know that it actually calculated the overhangs is, first of all, you're going to come in here to the fenestration table, fenestration glazing table here. It's page 4 of 9 on this report. You can see column 4 and column 5 are populated with widths and heights, and that's good. That's a good sign. Here's that funky multiplier issue that comes on. I've got a multiplier for that 6068 window of 1.004. That's not a big deal. Sometimes if you don't get that ratio right, it throws it way off, and then you might have a plan checker kick it back. So that's one of the areas. The other area is that we can go through, and as soon as you input overhangs or side fins, the calculations are going to tell the CF1R to produce this table, overhang and side fin table. So here are all your window in characteristics. So windows, we got several windows here. Here's your overhang depth characteristic. Column 2, column 3 is the distance up. So we can go through and check all these and make sure that our inputs are actually being characterized on the CF1R correctly. Left extension, right extension. One warning I do like to let people know, this is one of those areas that potentially you could over exaggerate the amount of overhang here. You know, and you know, we do teach in building departments to look for that. So, you know, be as accurate. I have a tendency to lean towards being on the conservative side. So if there's a weird situation with an overhang, model it conservatively, meaning round down, go to the small side. That way, you're not going to get any plan check comments like, "Oh, you overestimated this area." So I think that's good. So now that we have this compliance margin, what do you say we look at maybe reducing something else? I know a lot of my clients have actually asked me, "Hey, can you make that below roof deck insulation a little thinner? That way, it's easier to install, or eliminate it completely." I don't think 7.5% compliance margin or percent improvement is going to get us the ability to eliminate that below roof deck insulation, but let's take a look at reducing it. So I'm going to go in here and go to my roof area, and you can see that we have R38 ceiling insulation, R18 below roof deck insulation. We know that based on our characteristics here. This is option B for no air gap between the roofing material and the roof deck. This is the prescriptive requirement here, but since we're using the performance approach, maybe we could reduce that down. I would propose to my client reducing that down to R13. That way it's a normal density bat. It's 3.5 inch thickness. It'll fit nicely between the top cord members. It'll fit flush, and that might be just a nice little consolation. We know that most of the builders don't enjoy installing the stuff. Maybe we can make it a little bit easier. So anyways, any predictions on how that's going to impact our compliance margin? You know, so we took advantage of the shading, but we went back through and we said, okay, well, we'll give you a little bit here. We'll reduce it. So go ahead and type that in the chat window if you have a guess. So, and while you're doing that, I am going to take a drink of coffee in my awesome Code and Coffee mug here. Don't forget about our giveaway. We're going to be giving away one of these mugs to somebody who subscribes to our channel. So if you're subscribed to the channel, great. You're going to be entered into our random drawing to get one of these mugs, and then I'll contact you somehow through our registration site. So, okay, you guys ready to take a look at look at this solution? I actually had to do this separately. So, adding the shading, reducing the below roof deck insulation to R13 from R18 did impact our compliance margin, but it still complies. I don't know if you can see this, but let me bring, okay, that's the, yeah, B solution. So our compliance margin, go back here, is 4.7%. So I went from 7.5% down to 4.7%. I feel like that's still a pretty comfortable margin that isn't going to raise any red flags. Let's go back and check and make sure that I did my inputs right. So we can look at the opaque surface construct table here on page 6. I'm going to be looking at my attic roof. So I'm down here. It lists this characteristic, but I'm looking at the ceiling. I'm sorry, I'm looking at the roof up at the roof deck. So attic roofs, wood frame ceiling, 2x4 top cord, roof truss, 24 inches on center. Here it is, R13. I'm good to go. So accuracy is good. I feel very confident that I've got everything modeled correctly. We've got overhangs, and we were able to go back in, and the result of taking the time to model those overhangs got us a little bit bigger compliance margin. So now we can go back to our client and say, look, here's something that we can reduce your cost on. reducing that below roof deck insulation. So, all right. Any other questions before we sign off for today in our chat window? You guys have been pretty quiet in the chat window, but I appreciate those chats because it gives me some feedback on if you're understanding the information or not. But before we wrap up here, I wanted to put up our goodbye screen. You can see we have some resources here available for you. If you haven't gone to the EnergyCode ACE website, go there and check out our ACE tools. My favorite tool is the reference ACE. And you know what? Just for fun, since we have a couple of minutes, I'm going to take you to the reference ACE real quick and give you a view of that. So here's the reference ACE. You can see we've got the 2016 Building Energy Efficiency Standards, Part 1, Part 6. Part 6 is where all the regulations are, all 9 subchapters. We've got the reference appendices. These expand joint appendices. That's where you're going to find your JA4 U factors for common opaque surface, opaque assemblies. You've got your residential appendices, all the compliance manuals. So the res, non-res compliance manual, the res and non-res ACM reference manuals, along with the Title 24 appliance efficiency regulations. So that's a mouthful. My favorite tool by far. So, all right. On the flip side of that, we've got our resources. We're adding resources like crazy. There's an amazing amount of resources on the EnergyCode ACE website. Definitely go check out the Res Envelope application guide. That is a really good application guide. It's more like a magazine. You can flip through it. Great pictures, great illustrations. There's various case studies and examples of compliant assemblies there. So check that out. We also have the Res Mechanical application guide. So those are great. We've got fact sheets, trigger sheets. We have quick reference sheets for the prescriptive approach. So it's always changing. Go to EnergyCode ACE, register with the site by entering your email address. That will keep you up to date. We promise not to bombard you with spam, but you will be notified when Code and Coffee episodes come out or other training opportunities come out. So that said, I want to thank everybody for watching today. And if you're watching this in a recorded view, thank you for stopping in. Don't forget to hit the like button. That just makes me feel good. But hit the subscribe button. That way you're going to get updates and know when we're doing more episodes. So thank you very much. Hope everybody has a wonderful day, and we'll see you next episode.